Welcome to Science Made Easy online lessons. This is integrated science for SHS 1. And your tutor today is Enoch Kobina. To begin our lesson, let's answer these three questions. The first question, how tall are you? The second question, how much do you weigh? The third question, how much water can be filled in your water bottle? For us to be able to answer these three questions, what do we need to do? We need to measure. So the first question, to know how tall you are, you need to measure your height. To find how much you weigh, you must weigh yourself, either using a spring balance or a beam balance. Then third question, to know how much water you can fill in your water bottle, you need to measure the capacity of your bottle. Do you have a clue of what you are going to learn today? Yes, measurement. So today we are going to look at measurement. At the end of this lesson, we'll look at the meaning of measurement, the reason why we need to measure accurately. Then you also look at physical quantities. Then the types of physical quantities and their examples. We will look at units and the types of units and their examples. So to begin, the first lesson, what exactly is measurement? In other words, how will you define measurement? Measurement is the comparison of unknown quantity with the fixed quantity of the same kind. We can also define measurement as a technique in which the properties of an object are determined by comparing them to a standard quantity. Measurement can also be a collection of quantitative or numerical data that describes a property of an object or event. So these are a few definitions of measurement. Question: what is the study of measurement? The study of measurement is called metrology, and the person who studies measurement is called metrologist. Now let's look at reasons why we need to measure accurately. 1. To prevent wastage. For example, they have given you a contract to feed 5 people. How much quantity of rice will you use to feed these 5 people? Will you use 50 kg of rice to feed these people in just a day? Cook all 50 kg of rice? No. You will measure the quantity that will be enough for these 5 people. If you cook all the 50 kg of rice, it will become waste. So that's the reason why we need to measure the quantity of rice you will use to feed these 5 people. So to prevent wastage. Second reason is to avoid cheating. Measuring accurately will help you to prevent misunderstanding and also fighting due to cheating. Cheating can lead to misunderstanding and also what? Fighting among people. So to prevent this, we need to measure accurately. Measuring accurately also helps someone to be truthful. So it shows truthfulness. Fourth, maintain standards. It maintains standards. Fifth, it ensures reliability. You are reliable. Sixth, it also helps to ensure consistency. And lastly, which is so important, measuring accuracy helps to maintain integrity and honesty. If you are not honest, it will be very difficult for people to do business with you. As a businessman, you need to be reliable, truthful, not cheating others, and also being honest. When you are honest, your integrity will be intact. So these are some of the reasons why we need to measure accurately. Now, during our definition of measurement, we learn that measurement is comparing unknown quantity with a fixed quantity. So the question is, what is a quantity? What is a quantity? So now I want to look at physical quantity. What is it? How will you define? What do you say about physical quantity? A physical quantity is a quantity that can be measured and consists of a magnitude in units. Do you know the meaning of magnitude? Magnitude simply means the size or value of a quantity. So you are saying that any quantity that can be measured supposed to have a magnitude and units. These are the two characteristics of a physical quantity: having magnitude and units. Magnitude with direction or without direction, and also units. The size, the value. So examples of physical quantities, we can talk about mass, volume, speed, length, force, and so on. Measurement of physical quantities are also expressed in terms of units, and these units are standardized values. These units are being accepted by every country or all people in the world. That's why he said it's a standardized unit. They are having been accepted in the world. When you talk about physical quantities, it is being grouped or classified into two types. So now let's look at types of physical quantities. The types of physical quantities, we have base quantities or fundamental quantities. And two, we have derived quantities. Now, let's look at the meaning of fundamental quantities. Fundamental quantities. How will you define fundamental quantities? Let me give you this simple scenario to help you to define base or fundamental quantities. You know brick or block. The base quantities can be compared to a brick And you know the brick is the basic building block of what? A house. For us to get a house, we need to arrange a lot of these bricks or block for you to get what? A house. So now, with this in mind, how will you define base or fundamental quantities? Base quantities are quantities that cannot be expressed in terms of other quantities. So they are the foundation, the basis of all quantities. So that is the meaning of base quantity. And there are 7 base quantities, the fundamentals, the basis of all the quantities. They are 7. They are 1. Length, 2. Mass, 3. Time, 4. Amount of substance, 5. Temperature, 6. Electric current, and 7. Light intensity or luminous intensity. So these are the 7 base quantities, the fundamental quantities. Now, derived quantities. How will you define derived quantities? Let's go back to our break again. We said derived quantities can also be likened to the house that you have built. This house is being built from what? A collection of what? Bricks. Derived quantities are being, it's like a house which is being built from what? A collection of bricks. So now, how will you also define derived quantities with this scenario? Simply put, derived quantities are quantities that is obtained by combining 2 or more base quantities. So he's saying that you can get derived quantities when you add 2 or more of the base quantities or fundamental quantities. Example, volume. Volume is a derived quantity. To get volume, how many of the base quantities do you need? No doubt 3. For example, a volume of a cube. Cube is having the same size. So to get the volume of a cube, then you have length times length times length. So you get length cube, isn't it? So 3 of the length will give you volume. So the 3 of the base quantity, which is length, will give you the derived quantity volume. What about speed? Speed is distance over time. Distance is length. Distance you covered is length. You can measure in length. So distance here is length. And the time is also a base quantity. So length being base quantity, time being what? Base quantity. So 2 of different what? Base quantities will give you the derived quantity speed. You can go on and on. You can talk about power, density, acceleration. For example, acceleration is change in velocity over time, isn't it? And velocity is displacement over time. Displacement is also measured in length. Time is a base quantity. Displacement is a base quantity. So what we are saying, very simple, that to get a derived quantity, then you need 2 or more of these base quantities. the definition of measurement, we learned that measurement is about comparing unknown quantities with the fixed quantities. The quantity. What is a quantity? Quantity. We look at the quantity now. Then we said this quantity need to have a magnitude and what? Unit. So now I want to look at the unit of measurement. How will you define unit? Units are the standards of measurement used to express the values of quantities measured. The quantities you have measured is the unit that you use to express that value. So if you get 40 what? 40 meters, 40 centimeters cube, 40 kilogram or 40 grams. So the grams, the kilogram now become the unit that you use to express the values of that quantity you have measured. That is unit. Unit became acceptable in the whole wide world in 1960 when the General Conference of Weights and Measures recommended that the whole world need to use a common system of units. And this common system was accepted in 1960. And this common system of unit is called International System of Units or Standard Unit. And in French, it's called Système International de Units. In English, it's called International System of Units or Standard Units. So what is a standard unit? Standard unit is a unit of measurement understood and accepted by people and countries all over the world. We also have two types of units, like the quantities. We said we have the base quantities and base derived quantities. The same applies to the unit. We have the base or fundamental unit and derived units. Let's look at these two, their meaning, and also examples of these units, and you compare. So base unit. If you can recall, the definition of the base quantity, we said base quantities are quantities that cannot be expressed in terms of any other quantities, isn't it? So for us to be able to define base units, then anywhere you see quantities in the base quantity definition, you remove the quantities and fix units at that particular point. So let's go. Try. So you get base units are units that cannot be expressed in terms of other units. It's not so simple. Yes. So anywhere you see the base quantity, anywhere you see the quantity, face unit there and get the simple definition. There are also 7 base units. The base quantities, most with their units. So the quantity length, base quantity length, its unit or its base unit is meter. The base quantity time, its base SI unit is seconds. So it's in the table there. Then the base quantity mass, its base unit is kilogram. Then you have the temperature, its base unit is what? Kelvin. Amount of substance has a base unit of mole. Then Light intensity or luminous intensity has the base unit candela. Then electric current have the base unit ampere. And these units are also having their symbol. It is in the table below. Get used to them. The 7 base units and their quantities and symbols. And let's look at the derived units. The same way, let's pick the definition of derived quantity. Anywhere you see the quantity, face the unit there. So we said derived quantities are quantities being obtained by the combination of 2 or more of base quantities. So with this definition, anywhere you will see the quantity, remove the quantity and fix in the unit. So you have derived units are units obtained by a combination of 2 or more base units. It's also very simple. Examples: you have Newton, watt, meter square, and so on and so forth. There's a table below, which is the table contain the the derived quantity and its derived unit and symbol. So we talk about area, its unit is meter square. Then volume, its unit is what? Meter cube. Speed, you have meter per second. Force, you have Newton. Then density, you have kilogram per meter cube or cubic meter. Then we also have work energy having the same unit, joule. Then power, we have watt. Velocity, we have meter per second. Frequency is Hertz. Then quantity of electricity is coulomb. Then electric potential, its unit is volts. Then electric resistance, its unit is ohm. So what have you learned today? We have learned the meaning of measurement. We also look at the physical quantity. We said physical quantities, they are quantities that can be measured and also consist of magnitude and what? Units. We also looked at examples of these physical quantities. Then we looked at the 2 main types of physical quantities, being base quantity and derived quantity. We learned that derived quantity are quantities that are being obtained from the combination of 2 or more base quantity. Then we learned that base quantities cannot be expressed in terms of any other quantities. We also look at example of this quantity. We saw the base quantity, they have 7 or they are 7: length, mass, time, and the rest. Then derived quantity, we can talk about force, velocity, electric potential, and electric resistance. We also talk about units of measurement. We learned that unit was accepted in 1960 and was proposed by General Conference of Weight and Measure. And this unit is called standard unit or international system of units, and is being accepted by every country and all people all over the world. We also look at the 2 types of units, being based on fundamental units or derived units. We said derived units are units that cannot be expressed in terms of any other units. Then derived units are units obtained from combination of two or more base units. And base units or fundamental units are obtained, or they are units that cannot be expressed in terms of any other unit. We look at examples of this unit. The base unit we talk about second, Kelvin, meter, and the rest. 7 of them, 7 base units. Then we talk about units of derived units: joule, watt, coulomb, volt, ohms, and the rest. To end our lesson, I have assignment for you. Try your hands. There are 10 questions. So let's look at this assignment. Show by working the SI derived units of the following quantities. 1. We have area. 2. We have volume. 3. We have density. 4. We have speed. 5. Velocity. 6. Acceleration. 7 is force. 8 is work. 9 is power. And lastly, which is the 10th one, is pressure. You can WhatsApp your answers to the number on your screen for interaction. Next week, we will solve these assignments. We'll go into details, see how we derived this SI unit from these quantities. Until then, see you next week. Thank you. And also, please kindly share our WhatsApp through WhatsApp, or you can also share our channel on YouTube is Science Made Easy. Then on our Facebook page